Okay, thanks everybody for coming. I'm really pleased to be today, very pleased actually to go straight from the airport to give this talk, because it took me a little bit of negotiation with Lufthansa to get here. But anyways, very pleased to be here for the first time in Singapore, getting out of the airport. So I'm going to talk about some of the lessons learned in learning analytics and some of the directions that we want to take in terms of learning analytics, where we are seeing the field is going, and in terms of also overall adoption of learning analytics. When I was preparing my slides, I was thinking about a different configuration. I would be introducing things, and then George decided to bail on us. And then in a way, kind of, I'm now going to make some of the points that Shane and Nabil and a few others already made. But anyways, I'm going to try not to repeat many things. I think many of you already touched on the critical points in terms of today's educational landscape. But it's really hard to talk about learning analytics without understanding of that landscape, and in terms of thinking what are those critical factors shaping the needs for learning analytics. One of those critical factors is definitely that we are seeing the changes in students' population. Obviously, with the broadening of access to education, we are also seeing more and more so-called non-traditional students who are participating in our different educational institutions. In that sense, we mean those learners who are typically not just full-time students, but rather they have at least part-time employments, very frequently also full-time, and more even frequently they have some dependents. The other critical thing is that in that process, while we are having these type of learners, we are also seeing that universities are realizing, well, how we become relevant for our learners even once they graduate. At the same time, we are also realizing that many learners need to learn even further and become better at what they do over the course of life. And there are different types of initiatives. For example, Stanford 2025, which is talking about something which is called mission-oriented learning, where they are not seeing that connection between learners and universities end-to-end. Learners come to the university, then they spend 3 to 4 years, and they finish it as a final product, and that's the end. This is more talking about missions, thinking about what students are going to do for the next 5 years, coming to Stanford, spending a year getting ready for that next mission, and then completing that mission and then returning back. Of course, we can see only that as a potential vision. We will not be for sure what that is going to pan out. However, it is very important to think about different types of processes that are happening around us. At the same time, we are also thinking about different types of professions. A recent article by Oxford University researchers which discussed about different types of professions and different types of jobs which will completely disappear. And we are not talking anymore just about types of simple manual jobs. Even very sophisticated, and irony to be analysts who are working at Wall Street, who are making close to $500,000 a year, they are recently getting replaced by machines. Therefore, it's a kind of very interesting question, how we are educating our learners in that process when we are going to educate students who are going to do certain types of jobs that are yet to be invented. And of course, critical thing is for many of us, I'm not sure, but I think Singapore is doing pretty well. I know in many other parts of the world is that universities are generously defunded by their governments. We are expected to educate more students, yet we are getting less funding every year. So these are some of the critical, of course, factors that are shaping this process. In many cases, trying to address some of these needs, many institutions are trying to scale up their learning opportunities. Obviously, MOOCs are something that just surfaced that kind of need, that we have different learners with different types of needs. And we are also seeing by the demographics of learners who are taking MOOCs that they are typically people with at least undergrad and quite frequently also master's degrees and who are full-time employed and looking for some professional or lifelong learning opportunities. There's another important thing is we are thinking quite frequently about online learning as something kind of less active and typically referring to face-to-face learning as something that is happening which is much more active. Well, it's not really quite true. Even when we have a lecture hall like this one, and there's about 100 individuals in this room, it's really hard to even know what everybody is thinking about and to what extent they are completely disagreeing with me and what are the effective states, etc. I can pick up some of these social cues. But many institutions are trying to invent and reinvent their classrooms through flipping classrooms, through different types of active learning opportunities. And there are obviously many good outcomes that are being published in different types of studies. However, whether we are trying to create our learning opportunities more active, or we are trying to have more kind of scalable opportunities, we are typically turning to different types of technologies as a rescue, as a means that can help us to address some of these issues. However, even I was already just discussing this point as somebody who is trying to teach in a kind of a classroom, you are at least getting some of these social cues that you are seeing, who is following, who is not following, etc. When you are using technology, that even that kind of surface level as a lecturer, you can understand or see that disappears completely. And these feedback loops are with technologies getting weaker, especially with distance and so on. So the question is, then what's the role of learning analytics? In a kind of broader sense, we can see that the role of learning analytics is to try to reestablish or fix some of these weak or completely broken feedback loops. So I'm not going to go into any formal definition of learning analytics. We already heard that enough. I'm going to just jump directly into a couple of case studies that are trying to address. Shane already briefly discussed one of them, and I think it's an important example just to be discussed when we are talking about learning analytics. That's something which was at Purdue University. They wanted to address the challenge of student retention. And in their engineering program, they had that serious problem. So what they were trying to do is they were trying to make use of their learning management data interaction that the students had and they observed, plus also data they were tracking inside of their student information system. And inside of student information system, they had typical demographic, social, and economic data about their students. Based on that, they wanted to develop a predictive model which would tell them which students were at risk of failing a course. And they defined that problem as a kind of the outcome of that problem. They defined it as a categorical variable which had 3 categories: students at risk, students at moderate risk, and students at no risk at all. And what they then eventually decided to do, they translate that into traffic lights. Green light for no risk and high risk red light. These traffic lights were eventually then showed to both students and instructors. To evaluate this, they tracked a cohort of students of their engineering program, which had about 5,000 students for the period of 4 years from the enrollment to the completion. And as you can see, some of the stats, they are indicating that in some cases they had student retention for the group of students who took at least one course with core signals over, they basically had about 10% higher retention rate. So that was the major lesson learned. However, the question becomes, these simple signals, and Shane already talked about them, whether they are meaningful and to what extent they are precise, and more importantly, to what extent they are improving students' experience, whether they are improving teaching at all. And there was a follow-up study that was done also at Purdue University in which they decided now to go into text messages that were sent to students by their instructors as a follow-up of these signals that they were receiving. What they found is that when they were analyzing these messages, they were basically looking at the quantity of these messages as well as the quality of these messages by doing manual content analysis of the messages. So they first of all found that the major basically was that this system just improved, or better to say, increased the frequency of summative feedback, meaning that students were receiving weekly a message, well, you should be putting more effort if they were at risk. However, when they were digging deeper into the qualitative features of these messages, what they found was that they really primarily focused on summative feedback and very few instances of instructional or formative feedback which is provided to their students. And as we know, formative feedback is the one that is driving students towards better learning processes as well as better learning outcomes. So from this study, in a way, we can see that we cannot just simply expect that we dump a certain technology on our instructors without enough instructional training for them, as well as also this technology to allow them to drill down into the specific nuanced factors that are defining students' learning experiences before they can generate any feedback for them. However, many of these studies are typically in learning analytics looking at student retention, but it's not really a kind of necessarily always students' improvement. I'm in an institution that student retention is not a problem at all. So at the University of Edinburgh, our student retention is about 92 to 94%. And for those who don't make it, they are typically not making due to any academic reasons. They typically leave it. Similar is the University of Michigan. Their retention rates are similar as well, between 92 to 94%. And out of those, many who leave the universities are those who eventually make it to Harvard and they decided to transfer. So in a way, whether they are dropouts or not is quite questionable. So what I basically had as a question, or a problem better to say, is STEM education. STEM education, there are so-called gateway courses, which are in year 1. And inside of these gateway courses, they had a particular focus on students for whom science or STEM was not their major. Meaning, for example, psych students would have to study biology or chemistry. And so for many of those students, typically they would be less motivated, also quite frequently intimidated, and also not achieving that level of performance as they would be otherwise. So they decided to have a different metric for these students, and that metric was designed or called better than expected and worse than expected. Better than expected with respect to 2 critical features. One was previous students' grade average point, and the other one is better or worse than students aim to get in that particular course, right? So they asked students before enrolling the courses what was their goal in particular course. Then before they even started using just data, they wanted to do and investigate what was working well for their students at the University of Michigan who were more successful in some of these courses. And they rediscovered in a way something that is fairly known in educational research. First of all, those more successful students were pretty much more adaptive in a way. When they would try to do something in one way and they failed to learn in that way, they would try a different strategy. And the other basically approach or the other kind of strategy commonly observed in their case was that those students who were more successful were typically self-organizing into small groups to study together. And they would be typically exposed to different opinions or different perspectives, also getting regularly feedback from their peers. So those were the 2 things. They also decided to approach many successful students inside of this process and ask them to provide qualitative feedback into a knowledge base that they eventually constructed based on that feedback. Not only did they do that, but they also asked for permissions from these students to quote them and even reference to their names when they were in the future using some of their advice to their peers. They were building on some of the research which was found also in medical and public health domain, where typically patients or general population are much more inclined to accept an advice from their peers rather than professionals. So they were building in this case as well on similar principles. Eventually what they decided to do is they were building these and they were tracking students' activities over time, and then they were also trying to construct meaningful messages to their students on a weekly basis. And these messages were built, first of all, on self-determination theory by trying to provide certain rationale to students why studying a topic for a psych student is relevant when they are trying to study biology or physics. Second thing is also trying to be, in a way, empathetic and trying to be supportive in their process and also understand their problems. Then they will also be referring to their own personal goal and then saying what was observed for them and how then offering them clear advice, what are those effective steps and strategies they can take throughout the next week to improve their learning. They reported in several studies quite significant successes in terms of students' improvement, especially in terms of motivation and overall achievement of many students for whom science was not major. So I think this example is quite, in a way, encouraging to tell us that we should not be just focusing on retention, but we should be also trying to promote some effective learning and teaching strategies, especially inside of some of these large enrollment courses. And perhaps if I didn't tell that, many of these classes that they were trying to address at the University of Michigan would have groups of between 800 to 1,000 students. So what is the state of learning and adoption at a kind of larger scale and institutionally? I'm going to talk more about some work that I did with Shane and the project Shane led in Australia. which was conducted between 2014 and 15. So the report was published sometime late last year officially, although it was finished in June last year. So the overall kind of idea is that there are some good examples how learning analytics is used, but the question is there like any systemic use of learning analytics and institution-wide? Well, there are very few institutions that are using that in a very systemic way. I think if you are looking from that perspective, I think the most systemic approach that any institution has in the world is probably the Open University UK. But in a way, they are very specific institutions that are serving online and distance learners only, and also have many very standardized processes with much less diversity than you would find on a kind of a more traditional campus where you have many different types of programs. So how we measure the level of adoption and sophistication? Shane, together with George Siemens, who decided not to show up today, and Grace Lynch, wrote a paper in 2014, which was commissioned by Australian Government's Office for Learning and Teaching, published by the Society for Learning Analytics Research. They basically suggested this 5 stages learning analytics sophistication model. From some very basic awareness of learning analytics, where you are trying to say, oh, we are just touching on something, then to the level of certain experimentation, like these case studies that I just mentioned, to the point that we have like an institution-wide adoption where we have different types of tools and technologies that are being given to different stakeholders that we have inside of our institutions, to the point where many institutions are trying to make many of their decisions by leveraging predictive modeling, but also trying to offer a certain level of personalized learning, and through that basically to achieve organizational transformation. And to the point where you can see that organizations are between each other sharing data for the sake of creating more flexible pathways through our educational systems, so students can easily not only transfer credits, but also their, in a way, data that can also be used for personalizations when they transition to a different institution. So, what's your thinking where most of institutions are? And there have been many surveys trying, not even when learning analytics wasn't even coined as a term, they were trying to look into the use of analytics in higher education, and in many surveys. And typically those numbers are between 50 to 70% of institutions are in these first 2 phases. And what do you think where the remaining 30% are? Well, they are typically nowhere on this chart at all, right? So that's really one critical point. So inside of many institutions, we can find this narrative. There's lots of appetite to adopt learning analytics. But the question is, what's that appetite happening, and where that appetite is really leading, and what is the actual action happening inside of institutions, and how we are approaching to address this problem. This is the project that I mentioned. Our fearless leader, Shane, was leading it for about a year and a half. And in that project, we were trying to benchmark the entire Australian higher ed sector, all their 40 universities now, right, which are part of the public sector in higher education in Australia. And I would say, on average, Australian sector, higher ed sector, in terms of adoption of learning analytics, on average, but we know that on average means very little. Anyways, on average is probably most advanced in the world in terms of the adoption of learning analytics. And the idea was that we, inside of this project, would interview institutional leaders who were in charge of learning analytics adoption and implementation. Typically, those would be pro-vice chancellors or deputy vice chancellors for learning and teaching, quite frequently chief information officers, and so on. In addition to them, we also engaged with a group of internationally known experts in learning analytics, trying to also look at their perspectives, what is necessary for learning analytics to be adopted and widely accepted by many institutions. What we found and what we learned in many cases as well inside of Australia, and I'm now stealing one of Shane's slides because I thought it was really good, is that what we basically found is that many institutions are all inside of these first steps. But then when we talk to many of these institutional leaders, in many cases, well, we are doing a little bit of experimentation, they are doing some of these initial studies, and then the next sentence would be, and then we are getting into personalized learning. As if small little elves would come overnight and fix the problem of personalized learning without really any clear trajectory, how they will go into that process. That's really one critical thing. In some other cases, the answer was, well, we have this beautiful solution, so that's solved. I mean, analytics, why we are even discussing about that issue. But obviously, Shane also wisely pointed out in his study that there was although I'm not sure actually whether it was wisely or he was just whining and nobody listened to him. In 2012, in a paper in the special issue George and I edited, by the way, George, who didn't show up, and they were talking about a case study that generally there's lots of lack of learning analytics adoption culture. And Shane was talking about the University of British Columbia in their case as a process of their evaluation, which learning management system the institution should continue using or accept a new one. An institution decides to continue using the LMS in spite of data suggesting otherwise. Luckily, they didn't write about the University of Edinburgh, where we don't really have those types of problems. We only have like 7 or 8 LMSs that are supported by institutions, so it's really easy. So if we need to choose another one, we'll just add it to our portfolio, that's it. So that's basically one critical thing. So institutions don't really generally have culture developed in terms of data-informed decision-making. The other critical thing is, of course, we can basically complain on our decision makers as much as we want, but there are some of us who pretty much went through different ranks and managed to lead institutions. But we need to also start from ourselves and us researchers, right? And we are typically not necessarily ready or don't even have enough incentives to try to scale up certain solutions. Because typically that requires lots of persuasion. That requires that we go outside of our comfort zone as researchers. And so instead of me trying to convince a few other colleagues inside of my institution or maybe even my entire institution, it's much easier for me to write a few more papers and I'm just boosting my profile. So that's really kind of what is the incentive for academics as well and researchers to go out of that comfort zone and talk about different types of solutions and try to replicate different types of studies or think about ways how some of these analytics solutions can be adopted. So I said many things that where we are bad and what is really kind of not working so well and many weaknesses. So is there a way forward? And I think we need to be very constructive in terms of directions and what can be done. I'm going to talk about these types of directions in a way that I actually quite like what I learned from something which is business analytics. And only, I don't know, 2-3 years ago, I was so antagonistic towards business analytics, right? Until the point I was at a panel in Melbourne. And on that panel, there was a gentleman from Deloitte, which is one of these big business analytics organizations. And one key point where he actually completely got me was, he said, well, we can't really just start with data crunching and so on. We need to start from theory. So, I mean, they already know that even in business analytics. And we are in higher education, so why do we think that in our case, it should be something any different, right? And throughout all these 3 first presentations, there was a critical message, I think. Theory-driven or theory-involved analytics needs to go first. So, in terms of some specific frameworks, what is really interesting from business analytics is something that is used by McKinsey & Company, which is another big consultancy. And they are using this 3 phases or 3 elements model, which comes from data, model, transform. And they decide to have a fairly simple model that can be explained to many institutional leaders who really don't have much time nor resources to go into every step and any detail of that process. Rather, they basically just quickly walk them through these 3 quick elements that are necessary for many institutional leaders. So the first thing starts from data. Critical point is being created in data sourcing. We are very frequently going with this metaphor, low-hanging fruits. And this is not a criticism of what Nabil was saying. He was talking about very concrete, very specific, and I would say even to a certain extent, very theory-informed approach, how that is low-hanging fruit. But I'm thinking quite frequently that there are individuals who are trying to use organizations to use certain types of analytics just because they have certain data, for example, page hits, without really understanding what those page hits mean in particular contexts. Right. And Shane talked a lot about social networks. And we have these social networks, and we don't have to use learning management systems. Just simple course enrollments of our students in particular courses, especially when these programs are not as prescriptive as they could be in some countries, where students have lots of freedom to choose particular courses on their own. Inside of these courses, we run initially one study in Canada. Shane just mentioned it. And there was like a fully online master's program, and we had data for 10 years. Who is taking a particular course with whom? So for example, Shane and I would take one course, we would establish a link. Then Shane would go next course with Jen, and I would start next course with Carolyn. And this way we started building these social networks. What we found is basically in this way, we could explain about 25% of variability students' grade average point. Meaning basically that kind of just that access to other students, how quickly they could get information from somebody else inside of their degree programs, enable them for increased success. We wanted to replicate this study, and we went to Shane's university, and we pretty much tried to match a similar type of program, but it was happening on campus. And what we found in that program on campus, we initially kind of found some weird, interesting patterns, but looked at the surface as if centrality in such networks was kind of negatively correlated with student success. And then we decided to do the following thing. We decided to split the students to those who failed at least one course or more, and those who never failed a course. And then we found completely opposite patterns for these two groups of students. For those who failed at least one course or more, for them, centrality or social capital, if you wish, inside of these networks was negatively associated with their success. While for students who were successful, that basically social capital was positively associated with their success. Then we used even a bit kind of heavier artillery or machinery to analyze these data, something which is called exponential undergrowth models. And we basically were looking into the probability who students are more likely to take next course with. And what we found is that successful students were about 85% probable to take the next course with another successful student, and those who are less successful students were about 77% probable to take next course with another less successful student. And the mix between these two groups of students was not statistically significant at all, right? So that basically tells us a lot. And we can also get lots of data from textual discussions. Carolyn was talking about. We are also doing lots of research as well, trying to look into the levels of knowledge construction. But there are certain perks there with respect to the use of such data that is coming from learning management systems, so I'm going to touch on that very quickly. The other critical thing with respect to adoption is that we need to have on board IT. I was affiliated with one university in Canada, and their vice president academic had an initiative trying to encourage their staff to innovate with respect to educational technology, and they wanted to have also projects in learning analytics. So faculty members started working on these projects, they developed some interesting tools, and they wanted to pilot them. But piloting inside of real classrooms requested that they had to work with IT, and IT was supposed to give them access to data of their real deployed server and their LMS. And that basically where IT said, no, that's against our policy. And so you can see that basically inside of the same institution, IT has a different policy from their vice president academic. And so they had to basically spend a lot of time negotiating and trying to get their IT on board, because for IT, it was just another kind of unnecessary weakening of their perfectly secured system nobody uses. So we also need to be quite aware of limitations of our analytics. We are collecting lots of data and we are making lots of assumptions about some of that. One of these assumptions is that everybody talks about time online. But what does it mean, time online? And how we are even measuring that time online is something we need to be very careful about. Last year, we had a paper at LAC conference that basically looked into different strategies, how we are looking into the that kind of measurement of time spent online. And we are highly imprecise in that process, simply because quite frequently students don't log out. And so it may look as if a student spent about 3 days working on a single page. In some other cases, how do we know that a student really was looking at that page or not drinking the coffee, right? And so we investigated about 15 different types of strategies. And what we found was pretty much that in terms of just looking at the association between time online and students' grades, depends which of these 15 strategies we are going to use. We are going to basically influence variability explained for about 15 to 20% in some cases. And more importantly, what we also learned is that we don't know which of these strategies is best. Because we don't really have baseline data how to do that. The other critical thing, when we are now moving into this other component of the model, is that we should be using question-driven approach rather than data-driven approach. So why this is really important? We want to avoid situations like this. We have beautiful data, and we basically hired this consultancy, and they basically crunch data, and they have perfect answers, but yet we need to find the questions they were answering. And that's something I'm perfectly trained as well to do. Many computer scientists are trained to do that very well. We are really good at inventing a new technology and then looking at what that technology is actually solving. So we really need to be very careful in that process. The other question that occurred even, I think, earlier this morning is, but we had a paper last year in which we pretty much had a kind of a wise-ass message saying, well, learning analytics is about learning. Of course, but I think for many people that's not that obvious, right? And the question is, what's your operational definition of learning? I can't impose that. We know we have books about that. In my research, I come from self-regulated learning research, and I started from lots of work that Phil Winnie did at Simon Fraser University, and basically in that process, he summarized through what we know about learning from educational psychology through 3 major axioms. One of them is that learners construct knowledge through the use of tools to operate on raw information, and then when they are to create products of their learning, and then while they are creating these products of learning, they are using different types of standards to evaluate the extent to which the quality of these learning products is good, and also the effectiveness of the operations that are using to produce the quality of their products. And the other critical thing is that learners are agents, and learners are making their own decisions. So we have the same instructional design, but doesn't mean it will work in the same way for everybody. But rather basically depends on our internal conditions, of, as Phil Winnie calls it, and those internal conditions are our levels of motivation, our previous experiences, our study skills, and many things that can change or may not change as easily. So this really leads to another critical thing, and now I'm leading this learning analytics policy group at my university, and I made a promise. I hope I'll manage to succeed. But the critical point we want to enter into our learning analytics policies that one-size-fits-all doesn't work in learning analytics. And that's a really important message to be communicated to everybody. So Shane was already talking about this study in which we looked into the instructional conditions. So we were really, I mean, when we say instructional conditions, we were looking at 9 courses, and we had a sample of about 5,000 students at the University of South Australia, and we were trying to see what level of variability of students' grades we can explain when we put together all students' data into a single sample. And then what happens if we basically divide these into course-specific data? What we basically found is when we put together all these courses, we explain about 21%. But then when in terms of identified predictors, they are not necessarily something you can easily action. Number of logins or general time spent. However, when we divide these courses, in some cases, we were able to explain about 75% variability in students' grades, and in some other cases, 0. And when we talked to the instructor, where we explained 0, the instructor said, sure, because we are not using LMS. They were using Facebook, and most of the activity was happening elsewhere. So this is the kind of things that we need to know, and those are the qualitative insights we can't possibly ignore. Students' agency, time online, more time online, better learning. No. Not really. We also run a study, and several other studies are indicating that students who are typically spending the most of time online, they are just highly motivated students who are struggling a lot. And then there's another group of students who are basically not necessarily spending so much time. They are, on most of cases, spending even below the average in terms of time online, yet they are most effective learners. And that really builds on their prior knowledge, that builds on their knowledge of cognition and many other things that are known in the literature on education. So final component of the model. Participatory design of learning analytics tools is very important. I'm going to be a bit longer, as you can imagine. So participatory design of tools. This is really one of the critical things. We need to create tools that can be used and that have some meaning for our students. In most of the solutions that we currently see in terms of different types of dashboards, they are primarily designed by software engineers who have no clue about learning. So this is really one important message we need to understand. These tools need to be done through the involvement of our stakeholders. The other important thing is that these tools need to be for non-statistics experts. And many of them are designed for statistics experts. And I'm going to have a very specific examples what I mean by this. They can be very harmful. And these visualizations can be not only harmful for students, for example, who are struggling with their self-efficacy. And this is one common thing that we can see in many of these tools. I really don't know why somebody came up with the idea and why that person thought there was a good idea that comparing to the class average in terms of amount of time, etc., would improve students' learning. I really don't know. Anyways, at the University of Melbourne, Linda Corin and Paula De Barba, they did a study with their students trying to interpret and seeing how they are interpreting comparison with respect to class average. What they found is that even highly achieving students who had high expectations in particular courses, when they saw that they were just slightly above the average, that they thought they were doing well, although they were underperforming with respect to their personal goals. Students don't know what does it mean to be slightly above the average and how that translates to them personally. So that tells us also about our data science skills, and that has to be improved as well, because eventually they will have to go through their banking, etc. But at the same time, also tells us about learning analytics tools and why they are potentially not effective. The other critical thing is that I was found is that students really don't perceive dashboards as feedback. Our colleague, Abelardo Parra, ran a study at the University of Sydney. 1 year had a basically course. He's doing this fantastic instructional design in flipped classroom. And he basically observed that feedback was not really well perceived by his students. And he realized almost entire university there, but then he observed almost entire world as well is struggling with that. Next year, he said, okay, I'm going to introduce this beautiful dashboard. Results were still stuck at the same level. Nothing improved. Until next year, when he started generating personalized emails that were really very specific and tailored for students. That's where students started perceiving that as feedback. And basically grades and perception and the quality of feedback was much increased for 0.5 standard deviations. So this is really an important lesson that we need to have. Of course, I'm not arguing, and I basically had one talk recently talk about these visualizations, and people jumped at me, oh, you can't say about visualizations, they are so beautiful and successful. Yes, but they need to be embedded into tasks, and they need to speak task-specific language. If they speak resource-oriented language, it's meaningless for students. Because when I say resource-oriented language, it means page hits. It's useless. But if it's task-specific, then it can be potentially beneficial and needs to lead into some further interaction and need to be pedagogically informed. And of course, it is our critical thing as well. With analytics increase and data increase and the use of data, we need to really develop our capabilities, both as individuals as well as organizations, to use big data and our capabilities. Of course, it's not the idea that everybody becomes a data scientist, but we need to become data savvy. This is really one of the critical points. How do we do that? How do we achieve in that process that we can have data savviness inside of our programs, whether through our official courses or maybe separate courses, or each course does a little bit of it. That will not happen overnight. This is a process that will be happening over several years, probably a decade, until we get to that certain point. So there are other things with respect to analytics that are really critical and that can be sometimes quite embarrassing. One thing is really, what do we do if we detect some of these embarrassing things? How we are changing this policy. We ran a study, again, the same online master's program, and we were trying to test if we code all these students' interactions online based on Moore's interaction dimensions: student-student interaction, student content, and student-instructor interaction. And we found that in some groups of courses, we can see that increase in student instructor interaction leads to negative learning outcomes. So it's not that talking more to your instructor is negatively affecting students' learning, but rather that our instructional models are primarily designed to help students who are struggling. But what about students who are not struggling? How we are motivating them to exceed what we think that our students should be doing good on average? That's a really critical thing for us to think about. The other thing is what we are also observing in many things is that having all these beautiful tests, and the moment we impose a test in data, the moment we impose a test for our students, although initially they are following some very effective study strategies, the moment a test comes, almost all the students are following very same strategies. There's very little change, regardless of what they were doing in the past. And in a way, these external measurements are promoting performance-oriented culture, where students are primarily focused on tests and to study to test rather than to study to learn. And how then we flip that and think about how we are going to change to mastery learning rather than to promote performance. And this is something that our data will start surfacing. So the question is how that is affecting us. So the final point in terms of adoption of learning analytics, and this is a synthesis of the study that I was mentioning with Shane, that if we want to have effective adoption of learning analytics, we first need to develop strategic capabilities. That means that our institutional leaders need to be on board and need to be aware of benefits and the ways how we go through the learning analytics or general analytics in higher education, adoption or analytics in education. Only then we can have effective development of implementational capabilities and then general uptake by educators. Without that, in a way, we can see many individuals who are ready to accept many of these technologies, but then the overall systemic approach won't be happening. Okay, so a couple of final remarks. No matter what we do, we need to embrace complexity of educational systems. They are unique. Each university is unique. Each educational institution is unique. What works for one institution doesn't work for other institution. We need to basically not to battle that kind of complexity, but rather embrace it and deal with it. The other critical thing is that learning analytics is not a single discipline field. It's a bricolage field. It's a very multidisciplinary. So it's not a problem of learning analysts or to be just computer scientists or just to be learning scientists or just to be educational researchers or sociologists or psychologists or institutional leaders. It's a problem of all of us. And that's learning analytics. If you don't have all these stakeholders, and in particular students on board, you are not going to be successful in this process. Critical thing, I didn't really talk much about that, but very important, ethics. What do we do with these data? What do we do if we know that a student is going to fail? Do we communicate that or not? Is that our responsibility or not? Or the other way around is it good to always be transparent about saying we are collecting this type of data? Because that may lead into gaming of the system. Students are going just to do that to basically tick the boxes, although that is not going to promote their learning. And in such cases, there's something which is called Goodhart's law, which comes from economics. When a certain measure becomes a target, it ceases to be a good measure, right? So it's a really important thing for us to consider. There's something really useful in this process, which is called Code of Practice for Learning Analytics, which was developed by GISC, which is an organization that supports higher education sector in the UK. And it's a publicly available document. They had a big lit review, but then they also produced like a 10-pager document, which is easy to be used by many individuals that are involved inside of different types of organizations. My final point, critical thing, development of culture. We can see many beautiful, handsome examples as Brad Pitt in their Moneyball, where they are showing how learning analytics can be very effective and how team performance in their particular case in baseball can be very effective. However, there's a counter movie to that one is Trouble with the Curve, and which is with Clint Eastwood, who is quite aged, obviously now in his 80s. And he's also portraying an elderly scout who is looking for a talented kid who will be the next baseball star in the US. And all the predictive models are saying that the kid, one particular kid, would be a great success. However, initially his just gut feeling is that he won't be. There's something wrong with that picture. In the end of the movie, he basically eventually realizes the kid has a problem with his curve. For me, who is a European, I have no idea what it means. But I think for many Americans, it does. And I think the problem is that the kid will be just an average player. And that's the critical thing. And so we need to really understand, in spite of what we get from our predictive models, they will never be 100% accurate. And second thing is, there's so much tacit knowledge that is available inside of our institutions and our heads that we cannot just delegate all these decisions to particular predictive models to act on our behalf. Thanks very much.
Anyone? Reflection points?
The lunch is cold.
We'll do a short one. Yes, Mansur?
Hi, I'm actually
Do you want to introduce yourself? Or? I'm
Tom from MOE. I'm actually drawing up the question from the CDP. It happens to be the most popular question, so I thought it might be useful.
Sure.
The question is, what constitutes meaningful data on student learning and process of learning? And are there some criteria for assessing meaningfulness of data?
Okay, thanks very much. That's a great question. I think meaningful data really is something where there's no general set of rules that you can say this data is meaningful without understanding context. So what informs certain decisions about learning and understanding about learning is something which is meaningful. So in a way, if you're coming into understanding of data as a practitioner and you have your initial ideas what your instructional designers should do, then you are going to collect data that are meaningful and you are going to interpret them against your instructional design intentions. If you are a researcher, then you need to start from your theories and start basically to look into the proxies that are relevant for the measurement of certain constructs that you have in a particular context that can help inform some of your initial starting questions. And it's basically what I approach what is meaningful data.
Anyone else? Any other question? Reflection? Thoughts? Relevance?
All right. So perhaps everybody is hungry. We'll have a panel.
Yes. Yes, we'll have the panel in the afternoon so that we still have time for that. Maybe it's time to digest. And lunch is ready. So we'll be back at 1:45. Yeah, 1:45. Thank you.